everyone, this is Kalpana here. In this video, we are going to solve or we are going to prove the problem from mathematical induction. So let's get going. Problem: if x and y are natural numbers and x not equals to y, using mathematical induction show that x power n minus y power n is divisible by x minus y for all n belongs to capital N, that is natural numbers. Here capital N stands for natural numbers. So if x and y are natural numbers, here we are having x and y, right? So if these x and y are natural numbers such that x not equals to y, then we have to show that x power n minus y power n is divisible by x minus y for all n belongs to natural numbers. Okay, solution. So here firstly we will show that p of n is true for some n equals to 1, 2, 3. Okay, and actually you can just prove for n equals to 1. Okay, but here I will show you for n equals to 2 and 3 also. And in the second step you'll assume that p of k is true, and finally we'll show that p of k plus 1 is true using p of k. Okay, now let p of n be the given statement, that is p of n such that x power n minus y power n is divisible by x minus y. Okay, here x is not equals to y and x and y are natural numbers. Okay, we have to show that this statement is true for all n belongs to natural numbers. Now, when n equals to 1, put n equals to 1 in x power n minus y power n. You will get x power 1 minus y power 1, which is x minus y, right? We have to check whether x power 1 minus y power 1 is divisible by x minus 1 or x minus y or not. Okay, x power 1 minus y power 1 is again x minus y. So x minus y into 1's x minus y, right? So here we'll get the remainder 0 and 1 is the quotient and this is a divisor. X power 1 minus y power 1 is a dividend and 0 is a remainder, right? So here we have to get divisor into quotient plus remainder equals to dividend. Okay, so let's see what we'll get from this. So divisor into quotient, divisor into quotient, 1 plus 0 equals to x minus y, right, which is a dividend. Okay, so you can write x power 1 minus y power 1 by x minus y equals to 1, where x minus y is the divisor These are dividend and these are quotient, not remainder, sorry, quotient. Okay. Fine. Now, x power 1 minus y power 1 divided by x minus 1 is divisible. We got remainder 0 and quotient 1, right? Therefore, you can just write this as into 1. Here 1 is a quotient. Therefore, x power 1 minus y power 1 equals to x minus 1. X minus y into 1 is divisible by x minus y, right? Leaving remainder, sorry, not remainder, it's quotient, leaving quotient 1. Okay. Now let's see for n equals to 2. So from this we can say that therefore p of n is true for n equals to 1. That is p of 1 is true, right? So from n equals to 1 we got, right? Now we'll see for n equals to 2. When n equals to 2, put n equals to 2 in x power n minus y power n. You'll get x square minus y square, which is equals to x plus y into x minus y, or you can just write this as x minus y into x plus y. So we'll see x square minus y square is divisible by x minus y or not. Obviously, x square minus y square is a multiple of x minus y, so it will be divisible. X square minus y square, which is equals to x minus y into x plus y. Now we'll see whether x square minus y square is divisible by x minus y or not. So x minus y into x plus y gives x minus y into x plus y with remainder 0, right? This is a divisor, dividend and quotient. Okay, this is a quotient. So again from this you'll get x square minus y square by, take this to LHS, you'll get x minus y equals to x plus y, which is our quotient, right? Dividend by divisor equals to quotient. So it is clear that x square minus y square is divisible by x minus y, leaving quotient x plus 0. Okay, therefore x square minus y square equals to x minus y into x plus y is divisible by x minus y, leaving quotient x plus y. So from this we can say that p of n is true for n equals to 2. So therefore p of 2 is true, right? So from for n equals to 2 we'll get x square minus y square equals to x minus y into quotient x plus y, right? Now we'll see for n equals to 3. We know that x minus y whole cube equals to x cube minus y cube minus 3a xy into x minus y, right? Now bring minus 3xy into x minus y to LHS, you'll get x minus y whole cube plus 3xy into x minus y equals to x cube minus y cube. Now take x minus y common from these two terms, you'll get x minus y times x minus y whole square plus 3xy equals to x cube minus y cube. So x cube minus y cube is nothing but multiple of x minus y, right? Now we can write x cube minus y cube as x minus y into x minus y whole square plus 3xy, right? So which is x minus y into x minus y whole cube plus 3xy. Now we'll see whether x cube minus y cube is divisible by x minus y or not. So x minus y into x minus y whole cube plus 3xy gives x minus y into x minus y whole cube plus 3xy, right? Remainder 0, leaving quotient x minus y whole cube plus 3xy. So x cube minus y cube is divisible by x minus y by leaving quotient x minus y whole cube plus 3xy. So here the terms under square brackets is a quotient, right? And x cube minus y cube is divisible by x minus y. So from this we'll get dividend by divisor equals to quotient. Okay, fine. Now therefore x cube minus y cube equals to multiple of x minus y is divisible by x minus y, leaving quotient x minus y whole square plus 3xy, right? So x cube minus y cube equals to multiple of x minus 1 with quotient x minus y whole cube, square plus 3xy, right? So from this we can say that therefore P of n is true for n equals to 3. Therefore P of 3 is true. So now we have proved for n equals to 1, 2, 3, which belongs to natural numbers, right? Now we'll assume that the statement is true for some k. Okay. So now consider these three. You have when n equals to 1, x power 1 minus y power 1 equals to x minus y into 1. And when n equals to 2, x square minus y square equals to x minus y into x plus y. When n equals to 3, x cube minus y cube equals to x minus y into x minus y square plus 3xy, right? So all these are multiples of x minus 1, leaving quotient 1, x plus y, x minus y whole square plus 3xy. So we are getting, these are our quotient, right? Quotients. So we are getting equals to some into quotient, right? In general, right? When n equals to 1, we'll get x minus y into quotient 1. When n equals to 2, we'll get x square minus y square equals to x minus y into quotient. When n equals to 3, we'll get x cube minus y cube equals to x minus y into quotient, right? Just keep this in mind. Now, let's see. For k, here we have to assume, right? Assume that p of n is true for n equals to k. Then, or that is, p of k equals to, or p of k will be x power k minus y power k divisible by x minus y, right? So, as we seen earlier, for n equals to 1, n equals to 3, n equals to 2, n equals to 3, we are getting multiple of x minus 2 with quotient, right? For k also we'll get some multiple of x minus y with quotient, right? Then leaving quotient or some quotient, we can say, right? Because we are going to make an assumption. Then y x power k minus y power k equals to x minus y into some quotient. So let's name this some quotient as some q for quotient, say. Then we'll get x power k minus y power k equals to multiple of x minus y, leaving some quotient, right? So let's see, x power k minus y power k is divisible by x minus y or not. Just imagine. So x minus y into some quotient gives x power k minus y power k with remainder 0, right? So you can say that x power k minus y power k is divisible by x minus y, leaving quotient q. So from this, you will get x power k minus y power k, dividend by divisor. Dividend is divisible by divisor, leaving quotient some q, right? Fine. Now, this is assumption, okay? Fine. Now, we are having x power k minus y power k equals to x minus y into q. X power k minus y power k equals to x minus y into q. So from this assumption we got x power k minus y power k equals to x minus y into q. Again from this we'll get x power k equals to y power k plus x minus y into q, considered as equation 1. Or if you multiply both sides of this equation with x, you will get x power k into x equals to x times the RHS part. Then consider it as x power 1, then you'll get x power k plus 1 by adding powers equals to x into y power k plus x cube into x minus y, right? Consider as equation 2. So from the assumption we made, we'll get two equations. So now P of k is 2, right? Since P of k is true, we'll prove for P of k plus 1. Using this or this condition or by this assumption, we'll show that x power k plus 1 minus y power k plus 1 is true for, that is, x power k plus 1 minus y power k plus 1 is divisible by x minus 1. That is, we'll prove here, we'll show that P of k plus 1 is true whenever P of k is true, right? So now let's show this statement is true. That is, P of k plus 1 minus y power k plus 1 is divisible by x minus 1 using first equation. So you can split x power k plus 1 and y power k plus 1 as x power k into x minus y power k into y, right? Now, replace x power k by equation 1, then you'll get y power k plus x minus y into q into x minus y into y power k. This is equals to x into y power k plus x cube into x minus y minus y into y power k. Now write the terms involving y power k is equals to x y power k minus y into y power k plus x q into x minus y. Right. Now we can take y power k common from these two terms, then we'll get y power k times x minus y plus second term will be as it is then we'll get if you notice you're having x minus y in both the terms, so let's take x minus y common. You'll get x minus y times y power k plus x into q, right? So we got x power k plus 1 minus y power k plus 1 equals to x minus y times y power k plus x into q, right? Now let's see for equation 2. Simply replace x power k plus 1 by equation 2. You'll get x y power k plus x q into x minus y minus, write y power k plus 1 as y power k into y. This equals to x y power k plus x q into x minus y minus y into y power k. Now write the terms involving y power k is equals to x y power k minus y into y power k plus x q into x minus y. Now we can take y power k common from the first two terms. You'll get y power k times x minus y plus x q into x minus y. So notice you're having x minus y in both the terms, and you can take x minus y common from these two terms. You'll get x minus y times y power k plus x cube. The same thing. Okay, you'll get the same thing using 1 or 2, by using 1 or 2. So x power k plus 1 minus y power k plus 1 is x minus y into y power k plus x cube. Okay. Let's see, x power k plus 1 minus y power k plus 1 is divisible by x minus y or not. X power k plus 1 minus y power k plus 1 is x minus y times y power k plus x cube, right? Then x minus y into y power k plus x cube gives x minus y into y power k plus x cube, remainder 0. So here x minus y is divisor, x power k plus 1 minus y power k plus 1 is dividend, and this is your coefficient. So x power k plus 1 minus y power k plus 1 is divisible by x minus y, leaving this coefficient, right? These are coefficient. So you can just name this as some lambda, say. Then x power k plus 1 minus y power k plus 1 equals to x minus y into lambda. So therefore x power k plus 1 minus y power k plus 1 equals to x minus y into lambda is divisible by x minus y, leaving remainder lambda, or the terms under square brackets. So from this we can say that therefore P of n is true for n equals to k plus 1 whenever P of k is true. Therefore P of k plus 1 is true whenever P of k is true, right? So from this we can say that hence by the principle of mathematical induction, P of n is true for all n belongs to natural numbers. Okay. Now, what about x not equals to y and x, y belongs to natural numbers? Okay. And then we'll see which kind of equations we are going to get when x and y belongs to natural numbers. So we'll see examples. So in this problem, our coefficients, we are having some coefficients, right, belongs to some set of numbers. So let's see after observing some examples. Okay, we'll choose x power n minus y power n by x minus 1. We'll see for n equals to 1 and n equals to 2. Okay, let's take some x belongs to n and y belongs to n, that is x and y natural numbers such that x not equals to y, that x equals to some 2 and y equals to some 3. Okay, then we'll get x minus y equals to 2 minus 3, which is equals to minus 1. When n equals to 1, we'll get x power 1 minus y power 1, right? In the numerator, this equals to x, for x equals to 2 power 1 minus 3 power 1 equals to 2 minus 3. Here x is 2 and y is 3, which is nothing but x less than y. Okay, in this case 2 minus 3 equals to minus 1. Then x power 1 minus y power 1 by x minus y equals to x power 1 minus y power 1 is minus 1 by x minus y is minus 1, which is equals to 1, right? Belongs to natural numbers. Let's see for n equals to 2. X square, you need to find x square minus y square. X square minus y square equals to 2 2's 4. 2 square is 4, right? Minus 3 square is 9, which is equals to minus 5. Find x square minus y square by x minus y, which is equals to minus 5 by minus 1, which is equals to 5. Again, 5 belongs to natural numbers. Likewise, we'll see for n equals to 3, x cube minus y cube gives 2 cube minus 3 cube. This equals to 2 2's are 4, 4 2's are 8, minus 3 3's are 9, 9 3's are 27, equals to minus 19, right? Now, x cube minus y cube by x minus y equals to minus 19 by minus 1 is plus 19, which belongs to natural numbers. We won't get any 0, and we got 1, 5, 19, which are natural numbers. So we know that x power n minus y power n by x minus y equals to some quotient, right? So here 1 is a quotient and 5 is a quotient, and also 19 is a quotient. So from this example we can say that the quotients obtained when x power n minus y power n is divided by x minus y for some n which belongs to natural numbers is natural number, right? So for our satisfaction, let's see another example. Let's choose some x which is greater than y. Okay, let x equals to some 3 and y equals to 2. Okay, then x minus y gives 3 minus 2 equals to 1. When n equals to 1, x power 1 minus y power 1 equals to x 3 power 1 minus 2 power 1 equals to 3 minus 2 equals to 1. Then x power 1 minus y power 1 by x minus y gives 1 by 1 equals to 1. Belongs to natural number, and this is a quotient, right? Equals to, will get some quotient. Fine. Now when n equals to 2, find x square minus y square equals to 3 square minus 2 square equals to 3. This is a 9 minus 2 2's are 4. 5. Then x square minus y square by x minus y equals to 5 by 1 equals to 5, which belongs to n. Likewise, when n equals to 3, x cube minus y cube is 3 cube minus 2 cube, which is equals to 3 3's are 9 and 3 is 27 minus 2 2's are 4, 4 2's are 8 equals to plus 19, and x cube minus y cube by x minus y gives x cube minus y cube by x minus y gives 19 by x minus 1 1 equals to 19, which belongs to n. Here 1, 5, 19 all are positive, right? So here 1, 5, 19 are quotients, and also each number belongs to n. So when x is greater than y, for x and y being natural numbers, we'll get the quotient which belongs to natural number whenever x power n minus y power 1 is divisible by x minus y for some n belongs to natural numbers. So we will get a quotient which belongs to natural number when x power n minus y power 1 y power n is divided by x minus y for any natural numbers x and y, such that x not equals to y and n belongs to natural numbers. So we have seen a problem from mathematical induction followed by some examples. Hope you'll understand. We'll see you in the next video. Until then, bye bye.